Back with Chapter 5, Practice Exam 1. We're going to get right to it. We're going to keep this one short and sweet. This exam is only going to have 5 questions, although the value of these questions is, in my opinion, extremely high, and you'll see why as we start working through them. So if $12,000 is invested at 7% compounded monthly, then the future value of the investment, S, after X years, is given by that equation. We're asked to graph this function in GeoGebra, analyze the slope of the line over time, describe how it's changing, and what is happening to the investment. We do not need to submit the graph for the real test on this one either. We just need to describe what's happening. And then we're going to pretend that the 12,000 bucks was put into an account to be used for a child's college education on the day they were born, and figure out how much that account would be worth when they're 18 years old. And then if this child were to receive a full ride scholarship to college and decided to leave the account intact to use as a down payment for a house when they turn 25, how much would be in the account at that age of 25? And so we're going to go ahead and get right to it, everyone, with GeoGebra and Wolfram. So I'm going to go ahead and pull GeoGebra up here and pull my iPad out of the way for the moment. And we will see that we can go ahead and just copy and paste this equation as it sits into GeoGebra. And we may need to replace that S with a Y. I'm not sure yet. It looks like GeoGebra thinks it's okay. And remembering we can hold Shift to grab the axis and pull it down until we see something on this graph. So there we've got the equation with the 12,000 bucks. It's crossing the y-axis at the point 0, 12,000. And I'm going to go ahead and pull this out a bit. So we are just asked to sort of look at this in GeoGebra initially and see what's happening to this investment as time goes on. And so we can see here that it's actually growing at a pretty good rate right here. But if we look at like the first 10 years, for instance, it goes from 12,000 to about 25,000, pretty close to that. So it almost doubles in 10 years, which is pretty good. We've gained about, I don't know, $12,000 in this first 10 years. In the next 10 years, it goes from what looks to be about 24,000 or so, all the way up to almost 50,000. So it looks like it nearly doubles again during that time. And so it's growing much faster. So in this 10 years, it gains 25,000 bucks. Let's look at the next 10 years from 20 to 30 years. And you can see as we kind of go out here, everyone, that it's definitely getting steeper as we go forward in time. And so remember that we were, after 20 years, pretty close to the $50,000 mark. Let's go from 20 to 30 years and see what happens. It looks like from 20 to 30 years now, we're gaining nearly $50,000 in value. So again, this first 10 years was a gain of about $12,000 in value. The next 10 years was about $25,000 in value that we gained. And this next 10 years is like $50,000 that we're gaining. So the rate at which we're gaining money doubles about each time. The money doesn't double. The speed at which it is being acquired doubles about every 10 years. And so you can see that this slope gets very steep as it goes out here further. And if we were even to carry this out, everyone, to like 50 or 60 years, you can see that the slope becomes nearly vertical. And so this money, by the time it's been invested for 60 years, is growing at an extremely fast rate. What I would write on the iPad or to describe my answer for question A, let's go ahead and do that. As the age of the investment grows, the money actually grows at a faster rate. So for number 1, part A, the longer it is invested, the faster it grows. And so, pretty simply there, everyone, if we want money to grow, we feed it time, and it grows extremely fast. Being zoomed out this far, you can see how small the slope is here or how not steep the slope is down here to how extremely steep the slope is over here. Here the money is growing slowly. Here the money is growing extremely fast. And so we're going to pretend that this $12,000 was left in an account for a child's education to be used on their 18th birthday. And so unfortunately, we are not talking about the money over here because now it's a lot, like $800,000 in about 60 years. Isn't that nuts that $12,000 turned into 800,000 in 60 years? And so you can see again, this is an example of why rich people are able to stay rich. They leave money invested for very long periods of time. And so if we pull this out again so we can kind of look at it, everyone, we'll see that by the 18th birthday, this person is going to have a little over $40,000 in here, and Wolfram will tell us the exact amount, but it will be about just over $40,000 by their 18th birthday. And if they, for part C, were to leave it in there until 25 and use it as a down payment on a house, it would go all the way in those 5 years from about $40,000 to about $70,000. So in 7 years, they're gaining $30,000 for doing absolutely nothing. That's pretty awesome. So let's go ahead and give this to Wolfram, and we will take a look at this and get the exact numbers. So the child's 18th birthday, we're going to need to put the 18 in for, I can't remember if that was X or T, I think it was an X. And we will see that Wolfram gives us $42,120.31. So for part B, in 18 years, the $12,000 grows to be $42,120.31. That's pretty awesome growth. If you ask me, we more than tripled our money in 18 years for this person. And so then the next question, everyone, what if this person was to get a full ride scholarship, not need the money, and then pull the money out when they are going to buy a house when they're 25 years old? So the only change we need to make is to change this 18 to be a 25. And we'll see the impact of the 7 more years on that investment. So if the money is left in the account for 7 more years, 25 total, the value grows to $68,636.75. So hopefully we can see, everyone, that during that additional 7 years, we gained about $26,000, 26,500, something like that, for leaving the money in the account for 7 more years. And so that's a pretty nice chunk of change to put as a down payment on a house. And as you can see from the GeoGebra graph, just kind of ballparking this, let's play it out just for the sake of playing around. If we left the money in there for 60 years, it would get right up to 800,000 bucks. So $12,000 turning into 800,000 in 60 years. Again, so what a generational gift for a family to be able to pass down as time goes on. That's going to be it for number 1, everyone. Hope this was helpful.